Hello everyone, welcome back to my channel. In this video, we are going to be learning the topic salt analysis, which is in the chemistry practical syllabus for grades 11 and 12. Now, this is part 2 of the salt analysis series. So if you have not yet seen the first part, then I will give the link in the description box, and I request you to kindly watch the first part before watching this one. Now, in the first part, we had learned the identification tests for all the anions. Now, we are going to be learning the confirmatory tests for the anions. So, from the first part, you might be clear how to identify your ion. So, once you have identified it, you need to confirm that what you have observed is true. So in order to confirm that, you have to perform an additional test, which is known as the confirmatory test. Now, in the lab, you actually have to only perform one single confirmatory test in the exam. But when you are writing it down on your answer sheet, you have to write down two confirmatory tests for the anion. So you have to learn two tests for each and every ion. So even though we are learning two tests, you have to only perform one of them in the lab and show it to the examiner. But while writing, you need to mention both of them in the answer sheet. Now, we have to learn the confirmatory tests. So first, we are going to start with carbonate ion. Wait, let me change the color. Yeah, carbonate ion. So carbonate ion is CO3 with a charge of 2 minus. Now, the first test for the carbonate ion is your lime water test. Now, the lime water test is actually a continuation to the identification test which we learned. So in the identification test, we added dilute HCl to the salt, and I told you you would observe a colorless, odorless gas coming from the test tube, which is carbon dioxide. So once you are able to observe that, you need to pass that colorless, odorless gas through lime water. So you need to take a test tube with lime water, and if you are able to see that the lime water turns milky, that means if you are able to observe a precipitate being formed, then that milkiness indicates that carbonate ion is present, and that is a confirmatory test. Now, if you remember, in the first part, I had actually mentioned about this, and I don't think lime water will be there in the school, because if you are treating if you're just keeping the lime water in air, then it will directly absorb carbon dioxide, which is present in the atmosphere, and it will automatically turn milky. So the test that you are trying to perform will not be valid. So performing this test in the lab is something which might be difficult, and it is not possible, but you have to mention this test while writing. So when you are writing it in the answer script, you have to write that you are going to pass the gas through lime water, and if lime water turns milky, that confirms the presence of carbonate ion. Now we have to learn what is the chemistry behind the reaction. So why is lime water turning milky when you are passing the gas? So lime water is calcium hydroxide in the aqueous state, and the colorless gas from the test tube is carbon dioxide. I had mentioned that in the first part. So if you are adding carbon dioxide to calcium hydroxide, it is going to form a precipitate, which is calcium carbonate, which is the milkiness, which is responsible for the milkiness, and also water will be released as a byproduct. So this calcium carbonate is a white precipitate which is responsible for the milkiness which is present in the lime water. So I hope the chemistry is clear. This is the first confirmatory test. The second confirmatory test is the magnesium sulfate test. Now, the magnesium sulfate test is very simple, and this is the test that I would recommend you to perform in the lab, because I told you the lime water test is not possible, because the lime water will immediately react with CO2 from the air and it will automatically turn milky. So, doing the magnesium sulfate test will give you an apt observation, and you can easily confirm your observation. So now what you need to do is you have to take the salt solution, and to the salt solution you need to add a few drops of magnesium sulfate solution. This is your this is what you need to do. Now, when you are adding magnesium sulfate solution to the salt solution or water extract, you will see that a white precipitate is formed. And the white precipitate that you are getting should be treated with excess dilute HCl. And if you are able to see that this white precipitate it dissolves with effervescence. It dissolves with effervescence, then that means the carbonate ion is confirmed. So I will repeat what I just said. You have to take the salt solution in a test tube and add a few drops of magnesium sulfate, and if you're able to see that a white precipitate is formed, then what you need to do is you have to add excess dilute HCl to the precipitate. And if you are able to see that the precipitate is dissolving, that means it is soluble and it gives out a gas, there is effervescence, then that means the carbonate ion is confirmed. So what is the chemistry behind this? When you are taking the salt solution and adding magnesium sulfate, you are getting a precipitate of magnesium carbonate. Now, this magnesium carbonate is white, and when you are treating it with HCl, it gives out carbon dioxide gas, which is responsible for the effervescence. So, I will write the reaction here. Magnesium carbonate, that is the white precipitate, reacts with HCl and it gives out carbon dioxide vapors, and it also releases water, and it gives a salt which is magnesium chloride. Now, I think this is something that you have learned in grade 10. When a metal carbonate or a metal bicarbonate, that means a metal with HCO3 minus ion, if a metal carbonate or bicarbonate reacts with an acid, then what happens is you will be getting a salt, and by default there is water and carbon dioxide liberated. So this is a fixed reaction, and this is something you have learned last year. I mean, not last year, in grade 10. Okay, for the grade 12 students, you have learnt it 2 years ago, and for the grade 11 students, you have learnt it last year. So this is a reaction that you have learnt in grade 10, and the chemistry behind this test involves that reaction. So I hope the confirmatory tests of carbonate ion are clear to you. Now we have to look at the confirmatory tests for the next ion, which is acetate. So next we have acetate ion. Now for acetate ion, you have two tests again. The first one is the neutral ferric chloride test. Now, why do we say neutral ferric chloride? If you see, ferric chloride is a Lewis acid. So when you are preparing ferric chloride, some base like ammonium hydroxide or a weak base is added to normalize the acidity, because ferric chloride, even though it is a salt, it is a Lewis acid, so it is an electron acceptor. So as a result, we add a few drops of a base while preparing ferric chloride, and that will be neutralizing the acidity of the FeCl3 salt. So we need to learn what is this neutral ferric chloride test. So for the neutral ferric chloride test, you need to take the salt solution and you need to add a few drops of neutral ferric chloride. Now, if you are able to see a brown precipitate, if there is a brown precipitate which turns red, okay, a brown precipitate which slowly turns red, then that indicates your ion is acetate. That is the confirmatory test. And the brown precipitate is nothing but ferric acetate, CH3COO thrice Fe, ferric acetate, and that is the brown PPT which turns red. Okay, sometimes you may not see that it turns red. So even if you just get a brown precipitate, it indicates that ferric acetate is formed and your ion is confirmed to be acetate. Now the second test is the esterification test. Esterification test. Now for the esterification test, you have to heat the salt on a water bath. You need to take the salt in a test tube and you need to heat it on a water bath with a few chemicals. What are they? Now, to the salt, you first need to add ethanol. And you also need to add concentrated sulfuric acid. You have learnt about esterification test in grade 10. You have learnt that for esterification you require concentrated sulfuric acid because it is a strong dehydrating agent. Actually, you can even use concentrated, any other concentrated acid which works as a dehydrating agent. But normally we use concentrated H2SO4. Now, you can also use concentrated H3PO4, that is phosphoric acid, can also be used for esterification. But while performing in the lab, we normally find H2SO4 frequently in all the labs. So we often use concentrated H2SO4. But if you are using any other dehydrating agent, this reaction will still work. So once you are adding ethanol and concentrated sulfuric acid to the salt in a test tube, you have to heat the test tube on a water bath. So a water bath, normally in your school you will be having a water bath. If you are not having a water bath, then you can just take a beaker and fill it with water and place the beaker on a Bunsen burner. And once the water is hot, or if you can see that it's starting to boil, then you can place the test tube in it, and that is an alternative to the water bath. Now, when you are placing this test tube on a water bath and once it is heated, you will notice that a pleasant fruity smell will be observed. You will be able to obtain a pleasant fruity smell, and that is because of the ester which is being formed. So an ester is formed during the esterification reaction. So the ester that is going to be formed is ethyl ethanoate. ethyl ethanoate ester will be formed, and this is responsible for the pleasant fruity smell, and this confirms the presence of acetate ion. So you can do both of these tests in the lab. You can see which one is easier, and in the exam you can do the easier test. I think the neutral ferric chloride test is quite easier than the esterification one. But of course, if you find the second test easier, then you can perform that in the lab. Now we are moving on to the next ion, that is the halides. So for the halides, we have one test which is common to all of them, and there are two more tests which are applicable only to one particular halide. So let's learn all the tests now. So the third one is the halide ion X minus. So for the halides, there is a common test. The first one, that is silver nitrate test. Now the silver nitrate test is very simple. You just need to take the salt solution in a test tube, and you need to add dilute nitric acid, and also you need to add a few drops of silver nitrate. And if you are able to observe a precipitate, then that means a halide is present. Now, the color of the precipitate will vary depending on the ion, and also the solubility of the precipitate will also vary. So what is the difference in the color and the solubility we are going to discuss right now. So if you are able to get a white PPT, and I'll first tell you all the possible colors. You can get a white PPT, or you can get a pale yellow PPT. That means it's a very faint yellow color. Or you can get a yellow PPT, quite a dark color of yellow. Now, if these three precipitates are obtained, any one of these is obtained, then you have to first add excess amount of NH4OH, excess ammonium hydroxide. You need to add excess ammonium hydroxide to all of them, and when you're adding it, you need to look at the solubility. Now, the white precipitate has to be soluble. The pale yellow precipitate must be sparingly soluble, and the yellow precipitate should be insoluble. Now, sparingly soluble means partially soluble. That is a term that we use in chemistry, sparingly soluble. So, if the white precipitate is soluble in excess ammonium hydroxide, then that means chloride ion is present in your salt. So, this is chloride confirmatory test. If you are getting a pale yellow precipitate which is partially or sparingly soluble in excess ammonium hydroxide, then bromide ion is present. And if you are getting a yellow insoluble precipitate, then that means iodide ion is present in the salt. So depending on the color and the solubility, you have to determine what halide is present in your salt. Now let's learn the chemistry behind the reaction. Now the white PPT which is formed is actually silver chloride. The pale yellow precipitate is silver bromide, and the yellow precipitate is silver iodide. Now the white precipitate is the only one which completely dissolves in ammonium hydroxide. So when it is dissolving, it will be forming a complex, a coordination compound will be formed, and that coordination compound has a formula AgNH3 twice Cl. Now those who are in grade 11, you might not know what is a coordination compound. So you don't need to actually learn this right now. You can learn it in grade 12, but you can just make a note of this point, and you can try to learn at least the name of the compound. So the name of this compound is diamine silver chloride. Diamine silver chloride. That is the name of this soluble complex which is formed, and it is a coordination compound because there is a central metal which is attached to two ammonia ligands, and there is a chloride counter ion. So this is a coordination complex, and for the grade 11 students, you will learn about coordination compounds next year, so you don't need to worry about it right now, but you can just make a note of this and learn it for your viva. Now, the next few tests. I told you the next few tests are applicable to only one of the halides. So, there is one test only for chloride and there is one test only for bromide. So, for iodide, there is only one single test, which is this one, the silver nitrate test. For chloride and bromide, there is one more test. They are different tests, of course, but so you have to write two tests if you are getting chloride or bromide. Now, if you are getting chloride, the next test that you would have to write, or if you would like to perform it in the lab, you are most welcome. But I think these tests that I'm going to tell you are not as easy as the silver nitrate test. So I recommend you to write these tests in the exam, just like write it, but not perform it in the lab. So the second test is the chromyl chloride test, and this is only applicable for chloride ion. Now, the chromyl chloride test, for the chromyl chloride test, you need to take the salt in a test tube and add potassium dichromate crystals, and also you need to add a few drops of concentrated sulfuric acid. Now, this test tube, you have to heat it, and when you are heating it, you will observe that red vapors will be released. Red vapors will be released out of the test tube. These red vapors you are going to transfer into a new test tube, and in this new test tube, you need to add NaOH, sodium hydroxide, and you also have to add acetic acid and lead acetate. So this is quite lengthy and it is also difficult to perform. So I recommend you to just include this in the writing part, and for the test that you need to perform, please do the silver nitrate test, that is easier. So you have to pass the red vapors through a test tube which has NaOH, and after you add the NaOH and the red vapors, you need to add acetic acid and lead acetate. And after doing all this, what is the observation that you should get? You need to get a yellow PPT. There should be a yellow PPT formed. That concludes your chromyl chloride test. So if you're getting a yellow PPT, then chloride ion is confirmed. Now let's learn the chemistry behind this reaction. So the red vapors that you're getting are actually chromyl chloride vapors. What is chromyl chloride? It is CrO2 Cl2. CrO2Cl2. This is chromyl chloride, and this is very important for the grade 12 students because you are using chromyl chloride in a named reaction in grade 12, that is ETARD reaction. So you would have come across this term in that chapter when you're learning about Etard reaction. So chromyl chloride is CrO2Cl2, and when you are adding it to NaOH, you will first see a yellow solution is formed. That yellow solution is actually nothing but sodium chromate. Sodium chromate is Na2CrO4, and that is the yellow solution, not precipitate. The yellow solution that is formed initially is sodium chromate. Once you are adding these two chemicals, that is acetic acid and lead acetate, you will see a yellow precipitate is formed. Now, this yellow precipitate that is formed is lead chromate. Lead chromate, that is PbCrO4. So this is the chemistry behind the reaction, and you have to know this for your viva. Now, the third test for the halide ions, which is applicable only to bromide ion, is the third test, which is the globule test. Now, this is something which I don't think you can perform in the lab because you require chemicals such as carbon tetrachloride and chlorine water, which are highly reactive chemicals. And I don't think in your school lab you will be having carbon tetrachloride. But if it is there, then definitely you have to handle it with care, because both chlorine water and carbon tetrachloride are very dangerous and reactive chemicals. So I don't recommend you to do this test even if you have the chemicals in your lab. But mostly I don't think you will have CCl4 in the lab. So anyways, you have to include it in your written part. So I have to teach you this test. So you need to take the salt solution in a test tube, and you need to add around 1 ml of chlorine water, and you also have to add 1 ml of CCl4, carbon tetrachloride, and you have to shake it well. And when you are shaking it, if you're able to see an orange red globule is formed, uh, globule which is orangish in color, or kind of like a light red color is formed, then that means bromide ion is present in your salt. So this is the confirmatory test for bromide. And with that, we are done with the halides. So we have to now move on to the next anion. The next anion that you need to know is the nitrate ion. So let's learn the confirmatory tests for nitrate. Now, for nitrate, the first confirmatory test, which is repeatedly asked in the viva, and also it is something which we often perform in the lab, and that test is the brown ring test. Now, this test is actually easy to perform, but you have to be very careful with the way you perform it, because you have to tilt the test tube in such a manner that the concentrated sulfuric acid is added along the sides of the test tube and not directly into the solution. So I will first tell you what is the test, then you will understand it. So for this test, you need to first take the salt solution. You need to take the salt solution, and you need to add freshly prepared ferrous sulfate solution. So why should it be freshly prepared? Because ferrous ion can easily get oxidized to ferric ion by losing an electron. So in order to prevent this oxidation of ferrous sulfate into ferric sulfate, we have to freshly prepare the ferrous sulfate solution. So often in your lab, you might find ferrous sulfate present as a salt. So you need to take the ferrous sulfate salt in a test tube, and you have to add water, and immediately you need to perform this test. So you have to keep the salt solution ready, and immediately you need to pour the FeSO4 solution into the salt solution, and then you need to add concentrated sulfuric acid. Now the concentrated sulfuric acid must be poured along the sides of the test tube. So for example, if this is your test tube, normally when we're adding a chemical, we just add it straight into it. But when you're adding the concentrated sulfuric acid, it has to be added from the sides. So either from this side or from this side, you need to add it. So for that, normally you need to tilt the test tube at an angle so that it is easier for you to add along the side. And there will be so here you will be having the salt and the freshly prepared FeSO4, and then you need to add the concentrated sulfuric acid drop by drop, and you will slowly see that a ring like structure will be formed at the junction of the solution, and that ring is actually your brown ring, and that is the observation which you need to get. Now, in your viva, they will definitely be asking you what is the brown ring that is formed. Now, the brown ring that you are seeing is known as nitrosoferrous sulfate. It is known as nitrosoferrous sulfate, and they will also definitely ask you what is the formula of this. The formula of the nitrosoferrous sulfate ring is FeH2O5 NOSO4. Now FeH2O5NO is enclosed in square brackets because it is a coordination entity, and the sulfate is a counter ion. So this is the formula, and this is a coordination compound sorry, where the water and the nitrosyl group are acting as ligands, and the sulfate is a counter ion. And this coordination entity has a charge of +2, which balances the sulfate ions -2 charge. So this will be cancelled. So this is the brown ring test. It is quite simple, but I think getting the observation is not very easy, because often we won't perform the tests properly. So the second test that I'm going to tell you is actually very simple, and it is quite easy to perform as well. So the second test is diphenylamine test. Diphenylamine test. So the diphenylamine test is actually just adding diphenylamine solution to the salt solution. So you need to take a test tube which has the salt solution or the water extract, and you have to add diphenylamine. Now what is the formula of diphenylamine? It is C6H5 twice NH. It is an amine, it is an aromatic amine, and it is used for this particular test. Now when you're adding the diphenylamine, if you are able to observe a deep blue coloration, then that means nitrate ion is confirmed. That is the confirmation. Now, what is the difference between precipitate and coloration? Precipitate means you are able to observe a solid residue which is insoluble in the given substance. If you are getting a solid residue which is having a color, then that is a precipitate. Now, if you are just seeing that the solution in the test tube turns blue or turns any color, then that is known as coloration. So when I say deep blue coloration, you will not find any precipitate being formed, but you will notice that the solution, that is the salt solution, will turn deep blue in color if it has nitrate ion in it. And you will also notice the sides of the test tube will turn dark blue, and actually it is quite hard to remove the deep blue coloration. If you're just rinsing the test tube with water, it will not go. The deep blue color will actually impart a stain. There will be a stain on the test tube which is quite permanent and difficult to remove. So that is about the deep blue coloration. Now, the next ion that we need to discuss is the sulfate ion. So, the sulfate ion, SO4 2 minus. So, for the sulfate ion, we have two tests. Actually, for this one, the second test is a continuation of the first test. So, for the first test, what you need to do is you need to take a little of the salt solution in a test tube. So salt solution means salt plus water, and you need to dissolve the salt in the water, that is your salt solution. So you will be taking this and you have to add acetic acid and lead acetate. You have to add both of them. And when you're adding these two chemicals, if you're able to see a white precipitate being formed, then that means sulfate ion is confirmed. Now, what is this white precipitate which is being formed? It is lead sulfate. That is the chemistry. Now, the second test is a continuation. So, you have obtained a white precipitate. So, to this white PPT, you have to add hot ammonium acetate. Hot ammonium acetate. Ammonium acetate is CH3COONH4. So, what you have to do is you have to take a test tube, add ammonium acetate solution, and you have to heat it. And to that heated ammonium acetate, you have to add that heated ammonium acetate to the precipitate. And if the precipitate dissolves, if it is soluble in that hot ammonium acetate, then that means sulfate is confirmed again. And why is it actually dissolving? Because lead acetate is actually being formed, and because of that formation, the precipitate is dissolved. The lead sulfate actually undergoes a double displacement reaction when it is treated with ammonium acetate, because of which you will get ammonium sulfate and lead acetate. And if you know, ammonium salts are water soluble, and they are they are very they don't form precipitates easily. That is why we say when we are adding Na2CO3 to an ammonium salt, you will not find any precipitate being formed, because they are salts which can easily dissolve in water. So that is why the precipitate dissolves. Now, the last ion that we have is phosphate, and actually for phosphate, you only have one confirmatory test. So, for the phosphate confirmatory test, it is very simple. You just need to take the salt solution and add silver nitrate to it. That's it. And if you're getting a yellow colored precipitate after adding any AgNO3, you will that is the confirmation of phosphate ion. It is very simple. And what is the yellow precipitate formed? For the chemistry behind the reaction, you need to know that. So the yellow precipitate is nothing but silver phosphate, Ag3PO4. So that is all about the confirmatory tests of the anions, and I think you have understood all the tests. And of course, there are many Viva questions that can be asked. Mainly, the Viva questions will be from the chemistry behind all the reactions, which I have explained. But of course, there are additional Viva questions related to common ion effect as well. Like, for example, here in the silver nitrate test, and even in the this test, the sulfate confirmatory test, there is actually common ion effect taking place. So there are questions related to common ion effect and many other questions related to salt analysis itself in general. And as I had mentioned in the first part, I will be uploading a video just for the Viva questions. So you will definitely be learning many more questions which are not directly seen in the procedure from that particular video. So I hope you have understood all the confirmatory tests for the anions, and if you have any doubts, please feel free to drop in a comment, and I will look at the comment and respond to your query as soon as possible. So thank you everyone. Hope you enjoyed today's class, and we will meet in the next video. Have a great day. Thank you.